Welcome to Techno Bubble Lab. We are looking at some Arduino code here, which purports to provide multitasking without using the Millis, millisecond counters that I've noticed from other presentations. We are requiring the timer 1 support that Paul Staufregen has provided. And I've provided the links to that. To do that, we need to include this header file up at the beginning. And in this case, I'm using it on the Mega board. You can use this on the other Arduino boards, but you need to reassign the pins. And I believe the Uno, for instance, has the timer 1 support that you can use. So this form of multitasking and timer support, I'm claiming, is basically allows cooperative multitasking while maintaining the timing. In other words, no delay. And the problem with the Millis evidently is there's an overflow because we're constantly incrementing some counter, even though it's unsigned long. Eventually it overflows. So to counter that, what we are doing in our interrupt processing, if I can point you down to the interrupt service routine, this is called whenever the timer interrupts. By the way, before I do that, the timer 1, 2, and 3 are volatile unsigned ints that I've defined and initialized to 0. So whenever we get an interrupt, we're checking that timer, and if it's positive, if it has some value, some non-zero value, the only thing we're doing is decrementing. Okay. By the way, notice the decrementing occurs whenever there's a timer interrupt at whatever the rate that you've initialized it to. So we do the same thing on all three of them. Let's take a look at the initialization here. Okay, I've initialized 3 pins for output. Basically, they are the 3 pins that are connected to the cathodes of each of these LEDs. In common, they're supplied by 5 volts here, running in common to the 330 ohm resistors hooked up to the anodes. So the LEDs will blink when the cathodes become low, and that occurs whenever the output pins go low here. Okay, so that's the circuit wiring. The timer 1, in this case to 100,000 microseconds, which is equal to a 0.1 second interrupt rate. Okay, by the way, that can be modified and dropped down to 10 milliseconds or 1 millisecond if you have that requirement. So once we initialize it, we have to attach the timer 1 to the particular timer interrupt routine, which in this case is timer ISR in our case. Okay, so that's the setup. The loop is nothing more than, in this case, testing if the timers are 0, and the only way they're going to become 0 is if the timer interrupt decrements them down to 0, which implies that whatever that value that you put into the timers is multiplied by the timer interrupt is now elapsed. And in our case, if it is elapsed, we want to perform some function here. By the way, notice this is the trick where we read the pin, exclusive OR it, basically complement it, and then put it out again. Notice the other thing that we do is we reset the timer In this case, it's 7 times 0.1 seconds. So in other words, 0.7 seconds. We do the same thing for the timer 2 and timer 3. But we chose an odd, we don't want these timers to be harmonically related. So this one will be 1 second. The third one will be 1.4 seconds. So 0.7, 1, and 1.4. Hopefully you can. These are blinking at some odd frequency. By the way, they're 50% duty cycle, so that's because of this exclusive OR. So it's been an example of how to use the software timers. By the way, I make the analogy to these egg timers in that they are self-resetting. Eventually the sand drops down and they become empty. Metaphor. Thank you for listening.